they will start the nebulism, right? That's a angular motion. Commonly we say the angular motion, but there are two types of angular motion. There's rotational motion and circular. What is the difference? Rotational and circular. The angular motion means if body keep an angle, only change in the angle of the angular position. If they change, we call it angular motion. The angular position means that we can consider the position about a fixed point. This is a fixed point there, right? So here the position. Let's say if you choose the direction, this is the way the angle is measured. We start the angle measuring from this point, right? We start the angle measuring from this. That is the 0 degree position, right? And then let's see, we measure the angle to this direction. So and is this position? Let's say its angle is theta 1. So that is the angular position of this object. So this object is moving anyway, and at last after that is at time t is 0. At the time t equals t, the angular position, that's the line drawn from this point to the object. It's making an angle, right? So that angle at this point, let's say this theta 2 from this 0 degree line. This is the reference. We call this reference line. Reference line. So at time t, the position, angular position is theta 2. So then, if this angular position is changed with the time about a fixed axis or fixed point, we call the object is executing a angular motion, right? So any object is moving in a curved path, we can consider it as angular motion. And also, when an object is moving in a linear path, but that's position, that's a fixed point you consider that there. At the time, the position is there. And with the motion, the angular position also change. About this point, the angular position is also changed. So according to the observer here, then we can consider this motion as a angular motion. But according to the observer sitting along this line, so it's a linear motion, right? Mostly the angular motions we considered in a curved path for the easiest of our studying purposes, right? So the difference between this angular and rotation. So the angular motion is one. There are two types. That's a rotation and circular. The rotation is if the body like this. Let's say this is the body, right? I can move this body in a circle like this. Right? I can move like this. So then I can say this execute a circular motion. In a circular motion, the object should be moving in a circle with a constant radius, actually, right? But if I considering this body, that's I'm holding there and I can move like this also. So then we call this not the circular motion, actually. This is a rotation, right? In that case, the rotational motion, the object you rotated about a fixed point like this. You can see the objects that the points on this object, like say A, B, C, D. It's also executing a circular motion with the different radius, and it's also executing a circular motion with different radius, right? So the distance traveled by these particles differ. The individual particles, they're making a circular motion. So the combination of rotation, right? The complete motion is a rotation. But if you consider about the individual particle on this body, it's a circular motion. So can you identify the difference between the rotation means then it should move about axis. That's all the particles are not executing the same distance is traveling, right? So same angular displacement they face, but not the same linear distance is traveled. This particle A travels distance is much, and B travels more than A, and C travels more than, right? So then means that at the same time they're moving this larger distance means the C has larger velocity than A and B. So this thing we can discuss under this lesson, right? So angular motion. Uh, this is not the linear motion very well. This angular motion you can understand more than that, right? Because it is most of the cases, most of the terms and everything are correspondence. Very easy, much easy. Derive and define those things. Okay. Uh, this particle and the rigid body is two different. You need to know about that because here we are going to discuss total rigid bodies. We are considering not the rotation. We consider the circular motion mostly. That's a particle means the size of an object is negligible. That's negligible. The size is negligible. It's meant we can consider it as a particle. Right. When the object is more, let's as example, Earth is very big, but by comparing with the sun, when it's orbiting around the sun, the Earth also can be considered as a particle, right? So this particle, we considered the particles, but that is comparative, right? So it's relative thing. That's a, but actually Earth is not a particle; it is a rigid body. So this thing we'll discuss. Okay, first to write the topic. Angular motion. Okay, angular motion. Right there. The right the motion where the body moves along, motion where the body moves along the curved path, along a curved path at a constant and consistent angular velocity. A constant is angular motion, is an angular motion, is an angular. In angular motion, in angular motion, the angular position of an object angular position of an object angular position of an object is changed is changed with time. Is changed with time. Right. Angular motion, because after the right, yeah. Example, when a runner when a runner travels along a circular path, a runner travels along a circular path along a circular path. That's example. Then also the Earth is orbiting around the sun. Another example, the Earth orbiting around the sun. It's also we consider solar angular motion. Right? Okay, right there. Angular motion can be considered. Angular motion can be considered as rotational motion and circular motion separately. Angular motion can be considered as rotational motion and circular motion separate. Okay. The following definitions needed to be considered. Following definitions needed to be considered to study about the angular motion. To study about the angular motion. First, we know discuss about particle. To write this, what is particle? Okay. The particle is defined as an object whose mass is finite but its size is negligible. Okay, you can write it. A particle is defined as an object whose mass is finite particle is defined as an object whose mass is finite, but its size is negligibly small. But its size is negligibly small. Right, the second one is a rigid body. What's a rigid body? So rigid body means that when the object is moving, if its size or shape is not changed, so such a bodies are called the rigid bodies. Under the motion, it cannot be changed, right? Okay, then right, a body is said to be rigid. A body is said to be rigid. A body is said to be rigid if it does not undergo, if it does not undergo any change in size and shape. Does not undergo any change in size and shape. However, large external force acts on it. However, large external force acts on it. Okay. Okay. Then you know already this, that if a body is there at the time t equals 0, so after the time t body comes to this point, let's say it's more, right? So the particle A here and the B and the C, and also this is the time t equals 0, let's say. And after some time, the body is there now, right? Then A comes to A dash position, B comes to B dash, and C comes to B dash, C dash position. So then A, B, they're moving like this. During this motion, this all points and that moves the same distance. If A dash, that's equals B dash, that's equals C dash. Okay. So that motion you consider, you can tell this is a translatory motion. This kind of motion is called the translatory motion. Right. And when you rotate it, this rotatory motion, since these distances are is not changed, same, but angular displacement are same. Right. So we will define this to identify the difference between these two. Then the next term you can write that's a translatory motion. Okay. It's translatory motion. Translatory motion, and they write when different particles of a body undergo, when different particles of a body undergo same displacement, the motion of the body is called a translatory motion. The motion of a body is called a translatory motion. Okay, if you want, you can draw this and write this A dash equals B dash and C dash. Okay, then this one. The next one, write the rotatory motion. Rotatory motion. Write the bodies, then this subject is rotate to this point, this same angle they make. Right, yeah. When different particles of a body undergo, when different particles of the body, different particles of a body undergo same angular displacement, the motion of a body is called rotatory motion. The motion of a body is called rotatory motion. But different particles have different linear displacements. Right. But different particles have different linear displacement. This both also can happen, like this combined translatory and uh, rotatory motion also there. That's called the rolling body. This body is rolling, this moving in this line also, rolling like this. And also is make a rotating, that's moving like this. So this is the rotation and translation both. Just to draw this thing because here you know A dash is not equal to B dash not equal to C dash. But they A, B, C all make the same angle about this fixed axis. That's called axis of rotation. All right. Now we need to define these terms used to describe this motion. Right, then one by one, the terms we use to define this angular motion, we need to use some physical quantities to describe the motion. That's angular displacement, angular velocity, angular acceleration, time period, that's a frequency, angular frequency, and also the centrifugal acceleration, that's centrifugal force. So different terms we have to use there, right? So let's see what are the definitions of those, right? I'll erase this thing. Write the term that's angular displacement. We denote it as theta. Angular displacement. We consider a motion of body along a circular path. So the body is moving on this circular path. From here to here. Moving So axis of rotation of that's a fixed point. About this point, the object is moved, right? So you can say it's moving about this axis. I mean, at t equals 0 is here and t equals 0. Draw the tangent. Velocity has a direction, so it is moving the constant velocity. The v is along this direction. The displacement here is from, let's say, this point P to Q. So this, right? And the radius is r, then make an angle theta during this motion. Angular displacement, then you can define like the rotation above a point or the straight line about a particular axis in a particular sense, in a particular direction. That's line or this point. Make an angle like this. So that angle is called angular displacement, right? This is the way you need to measure this angle. There's no any particular direction, but this is a vector quantity. If you are consider about these vectors, vectorially you need to consider it's one direction the angular displacement is a positive. The opposite way you measure the angle is a negative. All right, sorry. Okay, first write the definition for angular displacement, and then we write the relationship between the angular. There's a relationship between this angular displacement and also this linear distances traveled during this motion. Right? So that relationship we can consider. And this the SI unit of the angular displacement is not a degree. Degrees are not used as a SI units. SI units for the measuring the angles are radians. So you need to know about the radian measurements also. That's radian. That's correct. Let's see how to convert this degrees to radians. Okay, first write there. First write the angular displacement is the rotation of a point, or a straight line, rotation of a point or a straight line about a particular axis, in a particular sense, or a particular direction. Right? This angular displacement is a scalar quantity. Right? This angular displacement is a scalar quantity. Angular displacement is a scalar quantity, and its SI unit is radian. Its SI unit is radian. Okay. Then right there. Under that, right, there's relationship between linear distance and angular displacement. Right under this. the relationship between linear distance and the angular displacement. Right there. Then right there. Consider a particle. Consider a particle moving along a circular path of radius simple r and its origin capital O. Moving along a circular path of radius simple r and its origin capital O. Right. Let the particle at P at time t equals 0, particle is at P, the point P capital P at t equals 0, time equals 0, at a distance simple r from the origin capital O. At a distance simple r from the origin capital O, rotates through an angle theta, rotates through an angle theta, and the particle is at Q at time t equals t. Particle is at point capital Q at t equals t. And during this motion, the linear distance is traveled is s. Linear distance is traveled, within bracket, right, the arc length. Linear distance is traveled, within bracket, the arc length. Linear distance is traveled, arc length is symbol s. Right, is this. Okay, then you can draw this diagram. Draw this diagram. We'll write the equations related to this. This relationship between this arc length and the theta we can consider, right? To draw this first, I will come right 1 minute. All right. Then we can write there in radian measurements. This theta you can write that is theta that is in radian. I will write in radian in rad. It's the arc length which equals to the arc length divided by the radius. Theta equals then s divided by r. So you can write s equals r theta. So this is the relationship between the distance and the angular displacement, right? So that means the distance, the linear distance traveled is equals to the radius multiplied by the angular displacement. Keep this in mind, this is not the displacement, right? It is distance. The distance traveled, right? Simple. That's why this angular displacement is not a vector quantity, it's a scalar quantity because distance is the scalar. So this height should be the scalar. So that's a scalar multiplied by scalar, only the scalar will produce. If vector multiplied by scalar, because radius is always a scalar. So then it cannot produce a scalar, right? So that's why this angular distance should be the scalar one. Now you need to know that what is this radian measurement. That's a science. Under this is the relationship between the linear distance traveled and the angular displacement. Then write the definition as a radian. Radian symbol is radian. Right. It's okay. Okay, the right radians. So definition was right. A radian, a radian is the angle subtended at the center. The angle subtended at the center of a circle by an arc by an arc equal in length to the radius. By an arc equal in length to the equal in length to the radius. Right. That's in this case you can say this is R and this is R. If this is R, arc length is also R, and this angle, angle is called 1 radian. So that is a definition. We know that that's a circumferential length is 2 pi r. So 2 pi r, that's arc length. So it's divided by the radius. It should equal to this theta in radius, right? First you draw this one. So 1 radian is defined like this. It's r, and its arc length is also equals to r. So that is 1 radian. According to this equation, you can get the arc length is r and r. So this theta equals 1 radian. And then after that, you can write in the since The circumferential length, circumference of a circle means circumference of, right, the circumference of a circle, circumference of a circle, radius r is equals to 2 pi r. Circumference of radius r equals to 2 pi r. Angle obtained at the center subtended at the center of the circle by the circumference. By circumference, yes, you can write as equals to the, this 2 pi r is the arc length divided by the radius. It is equal to 2 pi radians. That's equal to 2 pi radians. Yeah, sure. Yeah, I'll start this physical class from this Wednesday, right? Wednesday evening. I think it's a coming Wednesday also. I'm doing the class. Basically at 3:30 we'll start at the institute. So then you can arrange in class on Wednesday, Sunday evening. Is it okay? I think you all are okay for to start the classes Wednesday evening, right? Physically you can come because then no classes Sunday and when you change to the Wednesday evening. After school you can come. You can come 3 o'clock. It's better, right? Uh, Better than 3:30. Just try to come at 3. If you all come, then I can start the class. Not I'm waiting until 3:30. But you can come at 3 and 3:30. Because okay, this 2 pi r over that is 2 pi radians, right? We know that's a for a circumference of 360 degrees, right? So I'll erase this then you can say after this we can say that's 2 pi radians 360 degrees. So then that's pi radians is equals to the 180 degrees. So the 1 radian then equals to the 180 degree divided by pi. It's 3.14. So 1 radian is then it's about 57 degrees. It's 17 minutes and 44 seconds. And the Dravisha and Mario, are you okay to So we start a physical class at Wednesday at 3:30. No, sir. It's okay, no? So Ravisha was already given the when you Mario. What about you? Okay. I'll remind you on Wednesday also, right? I'll send a message in the morning. These days, you are going to school, and after the school, you have to come to class, no? Okay. And after the December one, we'll do some extra time we can take, and then to speed, they can't cover the syllabus, right? And then you have to do some papers and other things. Take a ride is that so 100 is this much of degrees. And because in this lesson, you cannot substitute any angles in degrees. You have to substitute with the radian, that's radian measurement. So it is important to know about the conversion, how to convert degrees into radians. And also, they ask in the question, sometimes they can give the angles, but these angles given by the substitute in the equation, uh, it's a better thing, right? Other way around, you can write this and 1 degree is equals to the, here this 1 degree equals to the 5 divided by 180, that's radians. 1 degree is equals to this. So the value is about 0.00175. Zero point 0.0174. This much of radians, that's equals to 1 degree. Can consider this as 0.75 170.175. Approximately against. Okay, note it down. Right? Right, here's an example right there. Convert following degrees or degrees to radians. Convert following to 60 degrees. How much in radians? And second one, that's 150 degrees. Third one, that's 50 degrees. And this one, and then these things, right? That's radians convert to the degrees, then, right? I will write down 1.57. All right, this is the next one is about see. 0.393 radians. Six on 0.62. Right. Convert these angles to degrees and these angles to radians. Okay. Basically, පටන් ගන්න හින්දා පුතා මේ next trick එක යාළුවෝ හරි ගන්න අය හරි කියන්න දෙන්න. next day ගම් physically පටන් ගන්නවා. ආනයිට දෙන්න. All right. It is 60 degrees. You can write that's 60 degrees. Yeah. Let's this 180 degrees is equals to radian pi. How much in 60 degrees? You can write as pi over 3 radians. Oh, that's equals to the that's pi is 3.14. You can write consider 3.14 divided by 3. In degrees, you can write it as 0.047. Second, 150 degrees. I over I'm divided by 150. 6 and this is 5. 5 divided by 6. Right. Sorry, in decimal, because when you calculating most of the decimal values are needed. It's about 2. 618. 50 degrees. I wrote 18 radians. That means you can divide this by 3. Divide by 3, that's 0. And to the 26 is 8. 1, 7, and 3 radians. Clear? Converting these two now. Radians. That's here we can say this 5 radians. That's equals to the 180 degrees. 1.57. 5 is 3 point. You can write as 3.1. We cancel this 2 and it's 90 degrees, right? And then 0.393 radians. 180 divided by 3.14 multiplied by 0.393. So let's simplify this. Use a logbook to the simplification. That's 22.5 degrees or 22 degrees and 30 seconds. Final one, 6 to 8. I'll erase this. Now 80 divided by 3.1, 0.2628. This is 0.2 then. That's 36 degrees. Okay. I forgot you to tell about this achievements of the previous batch student. The level results are released. My class, that's it's on the bigger class, right? So I recently started those classes. It's, before that, I will do the individual classes mostly, right? So the last year, that's all about 10 students are faced the exam, right? So all one has passed. It's a minimum results of the is pass is there. 3 years passes there for the student. Kerala Central College. That's the minimum one. So there are three students also there. Most of the students they have C passes. The 2 students only have the A. 2 students have B. And I think 6 or 5 students have A, and then no one has 6. No fail. They'll check in one. Yeah, our ලියපුවම හිටියා. ඊට වඩා ගන්න පුළුවන් හිටියා. ඒවා අර මොළ ඉඳන් කරපු ක්ලාසස් නේ. කියන්නේ වෙන පන්ති වලට ගිහලා අන්තිම කාලේ පේපර් පාස් වගේ ඒවා කරපුවා. ඒවා ඉතින් මොළ ඉඳන් මම නෙමෙයි කියන්නේ. මොළ ඉඳන් මේ ක්ලාස් එකේ මම මොන්ටන් එකේ ක්ලාස් එකක් පටන් ගත්තානේ. ඒකෝටනේ කොරෝනාවේ. ඊට පස්සේ ළමයින්ට ඔන්ලයින් කරගෙන ගියාද. ළමෙක් ඉන්නවා. අප්පා 40 ගණන් කෙනෙක් නම් 180 ඒකක් තිබ්බට ආදී කෙනෙකුට කරයි 3 years තියෙන. නැත්නම් කාරේ 1 year and B 2B ඒක 26 වගේ. ඒ 185. අප්පා 47 47. වල දැන් ඔයාලට කියන්නේ engineering යන්න නම් you have to get the credit score more than 2.1 විතරවත් ගන්න. Colombo it's so much higher than this, right? But high school, school in knowledge, in knowledge, you know that. That's my school, my class ki tamai it best saste. That's primary wagi. Yeah, Gampa 44. 3 years. ඊට පස්සේ ඉස්කෝලේ නම් කියන්න බෑ මොකද ළමයි ඉස්කෝලේ යන්නේ ඉස්කෝලේ ඉඳ හම්බුනේත් නෑ කොරෝනා ඉඳ වහලා තිබ්බේ ඊට පස්සේ පටන් ගන්නකොටම ඊස්ට් ඇටැක් එක වහලා තිබ්බා ඊට පස්සේ කොරෝනා හින්දා පැවුවා ළමයිට ඉස්කෝලේ මං හිතන්නේ මාස 3ක් 4ක් විතර තමයි ඒ ළමයි ඉස්කෝලේ එන්න ඊට පස්සේ ඔන්ලයින් මේවත් ඉතින් ඔන්ලයින් මම දන්නවනේ ළමයි එහෙම ඉන්නෙත් නෑ ඒකක් තියෙනවා virtual appearances තමයි තියෙන්නේ වැඩිපුර virtually appear but physically not හරි අපි sign in වෙලා හිටියාම හිතනවනේ high student යාර 5 students 3 students කියලා අහනවා ඕකේ sign in වෙලා ඉන්න ළමයි ඔක්කොම ටික උතන ඉන්නේ නෑ හරි ඒ හින්දා ඒක physically අපිට හිතන්න බෑ ඉන්නවා කියලා ඒ හින්දා මේක ගැන හරියට කියන්න බෑ හරි 100% ළමයි පාස් වෙලා තියෙනවා මේක ෆේල් වෙලා නැහැ ඔයාලා ෆේල් වෙන්න තිබා කොහොමද ඇත්තටම මෙහෙමයි ඔය රිසල්ට්ස් ගුරුවරු හොඳ හින්දා ගන්න රිසල්ට් නෙවෙයි ආයෙම එකක් පොඩක් එක්ස්ප්ලেইন කරලා කියන්නේ ඒ ළමයින්ගේ කැපවීම තමයි මම නම් කියන්නේ ඒක ළමයි තමයි රිසල්ට් එක ගුරුවරු නෙමෙයි උදාහරණයකට හිතමු the students who got 3 years ඒක මගේ පන්තියට ආවත් ඒ ළමයා 3 years ගන්නවා වෙන පන්තියක ගියත් ඒ ළමයා 3 years ගන්නවා ඒ ළමයි වෙන පන්ති නොයා ඉස්කෝලේ විතරක් ගියත් 3 years ගන්නවා ඉස්කෝලේ පන්ති කිසිම දෙයක් නැහැ ගෙදර ඉඳන් පොත් බලලා තනියෙන් ඉගෙන ගත්තත් එයාට 3 years ගන්න ගොඩක් ගන්න පුළුවන් කියන්නේ යා just having a inherent ability එහෙම තියෙනවා ළමයින්ට ඒක අපිටත් තියෙනවා මොකද මම I know that is practically because my master degree exam was at February month in this year. Right? Maybe February, March month of the master degree exam matter. February, after higher, after again, February higher, March 26th, exam. There are 8 exams, 2 weeks. එහෙම තමයි තිබ්බ දවස් 7. මාසෙකට එක්සෑම් දෙකයි. ඔයගොල්ලෝ දන්නවනේ February 14 තමයි මගේ පොඩි බබා ඉපදුනේ. හරි. so January මාසේ ඉඳන්ම wife hospital එකේ හිටියේ. හරි. hospitalized කරලා හිටියේ. pressure වැඩි blood pressure වැඩි. ඒතකොට ඔය මාසෙම මේ පාඩමක් කරන්නවත් කියලා එහෙම මොකොත් හම්බුනේ මම කරේ හැමදාම හොස්පිටල් යන්නේ. ඕගොල්ලන්ම දැන් ඔයාලට මම ක්ලාස් කරේත් හරි අමාරු වෙනවා. හරි. يعني උදේ හොස්පිටල් යනවා ආයෙ එනවා දවල්ට යනවා ආයෙ එනවා. තවත් පොඩි දෙන්නෙක් ගෙදර ඉන්නවනේ බලා ගන්න. ආයෙ හොස්පිටල් එකේ. මම මේ ෆස්ට් එක්සෑම් දවසේ ගියේ නෑ. මම මේ එක්සෑම් දෙක ලිව්වේ. තිබ්බේ এডুকেෂනල් සයිකොලොජි කියලා එක්සෑම් එකකුයි. teaching evaluation and teaching assessment කරන exam එක. ඒක මම ලියුවේ නෑ ඒ දෙකට මම ගියේ නෑ. ඒ දෙකට ගියේ නැත්නම් එදා තමයි මේ පොඩි කෙනා සීසා කරලා ගන්න කියලා ડોක්ටර් ඉන්න කියලා. පස්සේ මේ 14 වෙනිදා තමයි ඊට පස්සේ ඒක කරන්න තුනක්. ඉපදිච්ච දවස් ඉඳන් ඊට පස්සේ පොඩි ප්‍රශ්නයක් කරලා ඉන්නේ මැෂින් එකේ නේ හිටියේ. ඊට පස්සේ මැෂින් වල ඊට පස්සේ කොහොමත් පොඩි කෙනා ඉන්නවා කියලා ඉතින් ඊට පස්සේ ඔහොම හරි ඊට පස්සේ තිබ්බ එක්සෑම් දෙකට ගිහලා ලිව්වා. පාඩම් කරන්නේ නැතුව ලියන්නේ දැන් පෙරෝදයක් පාඩම්නකොට ගිහලා ලියනවා. හරි. මේ කලින් දවස් නිකන් පොඩ්ඩක් බලා යනවා ගිහලා. ඒ මාර්තු 18න් පොඩි කෙනා නැතුණා. කියන්නේ 18 25 වෙනිදා තමයි ඒ අර 7 days දානේ දුන්නේ. 26 වෙනිදා ගිහලා මම අන්තිම එක්සෑම් දෙක ලියුවා කොහොමද. දැන් මේ එක්සෑම් එකේ රිසල්ට්ස් දාලා තියෙනවා. ඊය සතියේ කලින් සර්. දෙක විතර කලින්. දැන් අර ලියපු නැති දෙකට නෑ ලකුණු කොහොමද. ඉතුරු එක්සෑම් 11යි 9ක් තියෙනවා. ඉතුරු ඒවා. කියන්නේ ලියන එක්සෑම්ස් 6යි ලියන්නේ නැති එක්සෑම්ස් 3ක් තියෙනවා. ලියන්නේ කියන්නේ ඒවා මේ ඔක්කොම 11ක්. 11න් 6යි ලිව්වේ මම. 3ක් ඒක අපි මේ C program එකේ ඉන්නකොට කරන ඇක්ටිවිටි එකේ ප්‍රසන්ටේෂන් කරන්න තියෙනවා, වයිවා කරන්න තියෙනවා. ඒකට තියෙනවා තව එක දවසට ටාස්ක් දෙනවා එක එකව කරන්න. ඒක දැන් ඒ 3 hour time එකේදී කරලා ප්‍රසන්ට් කරන්න ඕනේ. ඊට පස්සේ තව report එකක් හදලා finally දෙන්න ඕනේ. ඒවෙන් ලකුණු දාන එකක් තියෙනවා. මේ විෂයන් 3ක් තියෙනවා එහෙම. හරිද? ඊපස්සේ 6ක් තියෙනවා exam ලියන්න. අර දෙකක් තිබේ දෙක මම ලියුනේ. ඒ කියන්නේ ඔක්කොම ලියන්න ඒවා 8ක්. මේ දෙක ලියලා නැහැ. හරි. ඒකට මේවට ලකුණු රිසල්ට්ස් වලින් ඒ විදිහට දාලා තියෙනවා. ලියපු හයට ගත්තොත් එහෙම තියෙන්නේ ඔක්කොම මේ A4යි. A minor එකයි B එකයි. B plus එකයි. හරි. මේ රිසල්ට්ස් තිබ්බොනෝ. ඒතකොට දැන් MSc එකේ රිසර්ච් එක එලිජිබල් වෙන්න නම් ඔයගොල්ලන් ECT ස්කෝර් එක වගේ 2.5 වලට වඩා GPA එක තියෙනවා. 8.12 එක දෙලු. next batch එකත් එක කරන්න තමයි හිතන් හිටියේ. නමුත් වගේ රිසල්ට්ස් මේවට ලොකු රිසල්ට්ස් ඉන්න අර මේ දෙක නැතුවම 2.65 විතර GPA එකක් තියෙන අර දෙක නැතුව. හරි. ඒද එලිජිබල් දැන් මේ දෙක ලියන්න ඕනේ ආයෙ රිපීට් කරන්න ඕනේ නැහැ මොකද නැහැ. මාස්ටර් ඩිග්‍රී එකේ රිසර්ච් එකට එලිජිබල්. රිසර්ච් එකක් කරලා තියෙන භාගයක් ඒක අපේ තව ටිකකින් ඉවර වෙනවා. ඉතින් මං කියන්නේ අර එහෙම ඒ කියන්නේ ගුරුවරයෙක් ගාවට යන්න ඉගෙන ගන්න ඕනේ නැහැ. අතරම දැනුම කියන එක හොයාගෙන පාස් වෙන්න පුළුවන්. විභාගයක් වල දාගන්න පාස් වෙනවා කියලා හිතන්න අමාරුයි. මොකද එහෙම පාස් වෙනවා නම් if the teacher is the man who can pass the students, so all the students who come to the class would be get A pluses. Right? හැමෝම A classes ගත්තා නම් you can say like that, but in that also classes they having some people students but F classes F grades also we can't say that. So that's the teacher is not the man here, right? එහෙනම් ළමයි තමයි ඉගෙන ගන්න ඕනේ. ඒ හැම කිසිම කියන්නේ බලන්න මේ ගුණ කාස් එක්ක ගියත් අපි පන්තිම වෙන්න ඕනේ වෙන එකකට ගියා. සම්බන්ධ තේරුම් ගන්න තමන් තමයි මේක අචීව් කරන්න ඕනේ. තමන් තමයි ඉගෙන ගන්න ඕනේ. මේක සර් මම ඉතින් කරලා වලාට ඒ අරන් දෙන්නවත් B අරන් දෙන්නවත් එහෙම බෑ. You have to do that. We can guide you. You can follow it or not. And then you can reach there this week, right? හරි. පොඩි කාරණාවක් කිව්වේ. ඒ හින්දා මේ රිසල්ට්ස් ගන්න ඒවා කොහොම මොන ඒවා කියලා ක්ලාසස් වලින් වෙන්නේ ඔයාලට හරි ගයිඩ් එක වෙන්න එක සහ වැරදි දේවල් උගන්වන්න නැතුව බොරු උගන්වන්න නැතුව ඇත්ත උගන්වන එක තමයි. ඒක ඔයාලා දැනගන්න ඕනේ හරියට arrange කරගන්න. හරි. ඔයාලම තමයි කරන්න ඕනේ. කියන්නේ මම කියන්නේ ඔයාලා have to do that, right? Okay then. That's enough. We'll go for the next conclusion. Let's write the angular velocity. physical quantities as angular velocity use is not the here, it's omega, simple omega. This capital omega in Greek letter we write like this, simple omega is just like this. It's not the WO letter here, right? So it's angular velocity is omega letter, right? Thank you. Okay, then angular velocity is similar as the linear velocity. Linear velocity we define as rate of change of the displacement. But angular velocity is the rate of change of the angular displacement, right? So you can write the definition. The rate of change of angular displacement, the rate of change of the angular displacement, rate of change of the angular displacement is defined as the angular velocity. Is defined as the angular velocity. It's angular velocity. This angular velocity is a vector quantity, right? So first you write the angular velocity is that is change in angular displacement divided by the time taken to change the velocity, right? Time taken. So you can write omega equals delta theta divided by delta t. I'll change this delta t and then this, let's say delta theta. The linear velocity moving in this way, let's say v. The distance traveled. Let's say that distance traveled in this way delta s. You can write this as the equation. It's omega equals delta theta over delta t, right? The SI unit of omega is the theta is measured in radian and time measured in second. That's radians per second. That's a dimensional formula. T minus. ඔයාලට MSc exam එකේ හොඳම කතාව තමයි දැන් මේ MSc exam එකේ ලිව්වේ 19 දෙනෙක්. හරි. ඉන්ඩෙක්ස් එකට මිති 19. ඒකෙන් රිසර්ච් එකට එලිජිබල් 9 දෙනා. තුරු 10ම බේස්. ඒගොල්ලන්ට රිසර්ච් එක කරන්න හම්බෙන්නේ නැහැ. ඒගොල්ලෝ they can take the diploma එක අරගෙන ඒගොල්ලන්ට ඊට පස්සේ එතනින් නවත්තන්න දෙනවා MSc. ඒගොල්ලන්ට තියෙන ප්‍රශ්නේ තමයි දෙකක් ලියන්නේ නැතුව මම එලිජිබල් වුණේ කොහොමද? ඒ එක්සෑම් දෙමි ලේසියව නෙමෙයි. ෆිසික්ස් වල තියා ක්වොන්ටම් ෆිසික්ස්. අපි මේ ඒවල වල උගන්නන ඒවා තිබ්බනම් අපිට හිතන්න පුළුවන් ලේසිවක් කියලා. ඒවල වල එහා ඒවා තමයි කැම්පස් එකේ උගන්නලා එහාට කියනවා. MS වල සාමාන්‍ය තියෙන. BSc එකේදී සමහර ඒවා කරලා තිබ්බ හින්දා මට මතකද කරන්න පුළුවන්.
සමහර ප්‍රශ්න තිබ්බා විභාගයට මම ගියාම ඒ වෙලේ තමයි දැක්කේ ඔය කියන්නේ. ඉතින් මේවත් ඒ සිලබස් එකේ තිබිලා තියෙනවා කියලා. ඒ වුණත් එහෙම ලියන්න පුළුවන්. එහෙම ඔයගලන්ට උනත් එහෙම හරියට ඉගෙනගෙන තිබ්බොත් බේස්මන්ට් එකේ තියෙන මූලධර්ම හරියට ඉගෙනගෙන තිබ්බොත් ඕනම විභාගයට ගිහිලා ඒ එවල විභාගෙදී තියරිය ගොඩනගාගෙන ලියා ගන්නත් පුළුවන් සමහර ඒවා. කියන්නේ අර උදාහරණයකට කියන්නේ දැන් ඔයගොල්ලෝ දන්නවා ඇති දැන් ෆාදර්ස් ලයිෆ් ස්පීචස් දෙන්නේ. මොකද දැන් ඒකයි මගේ පැත්තේ හාමුදුරුවෝ බණ කියනවනේ. දැන් මේ හාමුදුරුවෝ බණ කියන්නේ බුදුහාමුදුරන්ගෙන් බණ අහලා නෙමෙයි. කවදාවත් දැන් මේ ඉන්න හාමුදුරුවෝ බුදුහාමුදුරන්ගෙන් බණ අහලත් නැහැ. ඒකට බුදුහාමුදුරුවෝ කිව්වේ මොකද්ද කියලා හරියටම දන්නෙත් නැහැ දුවන. ඒ වගේ ඒගොල්ලන්ට අර ඒක අවබෝධ කරගත්තාට පස්සේ කියන්නේ හරියට මේ මොකද්ද කියන දර්ශනය අවබෝධ කරගත්තාට පස්සේ ඒ කියන්නේ ඒගොල්ලෝ මූල ධර්මයේ හරියට දන්නවනම් ඊට පස්සේ යාළුවා ටිකක් අර බුදුහාමුදුරුවෝ කිව්වා වගේ හිතලා කියන්න පුළුවන් විදියට ඒක හැදෙනවා. ඉතින් මේ ෆාදර්ස්ලා ස්පීචස් දෙන්නේ සෑහෙන එහෙම ගොඩක් ඒගොල්ලන්ට නිකන් ඒක එනවා ඒගොල්ලන්ට. ඒ කියන්නේ ආධ්‍යාත්මය ලබා ගන්න පුළුවන්. කියන්නේ අර මූල ධර්ම හරියට දැනන් ඉන්න ඕනේ ඒකට. ඒකම නොදන්න අයට ඒක කරන්න බෑ. ඔයගොල්ලන්ට පුළුවන් අර කිව්ව දෙයක් බලාගෙන මේක කිව්වා මේක තිබ්බා පොතක් බලාගෙන මේම මේකයි කියලා කියන්න විතරයි. ඉතින් ඔයාලට අර එහෙම ගොඩක් ස්කූල් ළමයි විභාග වලට පාඩම් කරන විදිහත් එහෙම විදියනේ. තක තිබ්බොත් ලියලා දුන්නොත් ඒක කරා ඉතින් එහාට ආයේ මෙලෝ දෙයක් නෑ. ගානක් හදලා තිබ්බා නම් ඒ වගේ එකක් කී විදියට බලාගෙන අනිත් ගාන හදන්න පුළුවන්. අය අලුතෙන්ම ගානක් ආව ගමන් දැන් දැකලවත් නැති එකක් නිකන් ඒක හිතන්නවත් බෑ අමාරු කොහොමද කරන්නේ. අනේ එහෙම නැතුව අර if you know the fundamentals well then you can get an idea, that's a comprehension about it, and then you can do it also. Okay, this dimensional formula. This even this angular displacement is a scalar quantity. This is angular velocity is a vector quantity. Angular velocity is a vector quantity, right? So these are the axial vectors. This angular velocity, angular acceleration, those are axial vectors, not the polar vectors. Axial vectors are the vectors which acts along a axis of rotation. Rotation axis එක දිගේ තමයි මේ velocity එක එන්නේ හැටිස්. And if this the axis of rotation is passing through this perpendicular to this plane. So this angular velocity vector is about this angular velocity. We can write this is into the board or out of the board. To get the direction of this angular vector, there's a rule is called the right hand corkscrew rule. Right? So corkscrew එකක් ගත්තොත් අපි අර corkscrew අපි මේ object එක rotate වෙන පැත්තට මේ ඇඟිලි ටික මෙහෙම curve කරනවා. Right hand. හරි? මේ පැත්තට යනවා. So this along the axis, the middle finger, the thumb is directed towards the direction of the angular velocity. That is along this axis, just away from the plane. Right. So if you are considering right? If this will rotate, so this direction like this, right? It is rotating to this direction, right? Its angular velocity is in this direction. Omega is in this direction. Omega and angular acceleration is also the same way, you can see. And you can first you write it to there, then after this put a sign right there. The angular velocity is a vector quantity. Angular velocity is a vector quantity angular velocity is a vector quantity the velocity is a vector quantity
and its direction
is given by the right hand
cos square rho.
cos square
Rho. मैं रोल लेकर दिया ना
you can see this angle is rotating into this direction. That's the omega is in this. That's axial vector, right? And also right there, that's a that's a small topic. This is right hand cos square. Right hand cos square. Okay, right under that. Right, if you hold, right the rule. If you hold the axis or the axis of rotation with your right hand,
axis of rotation with your right hand
and rotate the fingers in the direction of motion of the rotating body and rotate the fingers in the direction of motion of the rotating body. Then thumb will point the direction of the angular velocity. Then thumb will point the direction of the angular velocity. Okay, and
the top पे का
okay, top पे का गत्ते बम्बर again.
बम्बर या कपी तुम
Espero que ahora que no quieran.
पहले नहीं करते हैं ये velocities मैंने क्या रखे so
They get an idea of the direction. Stop. It's important, right? right? Okay, then right there, that's a relationship between angular velocity and linear speed. Speed के what that is, right? The relationship between angular velocity and linear speed or linear uh, the linear speed के what that is, right? This direction debate we can keep in mind. It's important for the quantities also. Because some other countries we define with this angular velocity, so they having the same direction as the direction of the angular velocity. So then you need to know about this. How you get the relationship between these? So right, let's say this omega. This we know that S equals R theta, or right. So that's delta S. If the change in displacement, that should equal to R is a constant and change in angular displacement. So divided by time, the rate of change of the distance is equals to the rate of change of the angular displacement, right? So this is equals to the linear velocity, and this is equals to the angular velocity. So you know this. So then you can write this equals R omega. You need to keep this in mind also. This when the object is moving along a circular path, it's having a linear velocity at a point. So at that point, the linear velocity, you can write that the radius multiplied by the angular velocity at that point, right? So this V equals R. It's clear. Let's say that the object is taking a turn in a road. Okay, වංගුවක් ගන්නවා කියලා. ඒ වංගුවක් ගන්න වෙලාවේ වංගුවේ කන්න මොහොත එතනදී තියෙන. You know that in normally in practical situations, this radius is not a constant. If you're taking a turn, that radius is not the pure circle, right? මෙතනදී radius එක එකක් මෙහෙටදී වෙන එකක් කියලා R2 this R1. And then මෙතන velocity එක is equals to that omega at this point they multiply by this R1. Then එනකොට ඒක වෙන එකක් වෙන්න පුළුවන්. In the case of the tornado or the cyclone effect, you know, they are moving like this spiral එකක් වගේ ඔහොම යන්නේ. So that means with the radius increases, omega increases, the velocity also increases. අනිත් පැත්තට වෙන්නේ මේක මේ ගොඩක් ඒවා මෙහෙම එකට ලං වෙනකොට collapse වෙනකොට ස්පීඩ් එක වැඩි වෙනවා. එහෙම වෙනවා. ස්පීඩ් ඕනාට වැඩි ස්පීඩ් එකක් ගන්න ගියොත් එහෙම they need to take the larger radius. ඒ තමයි වංගුවකින් එන velocity එක වැඩි වුණා පස්සේ විස්තර කරනවා වංගුවෙන් එළියට යන්න බලන්නේ ගොඩක් වෙලා. වැඩි radius එකක් ගන්න ඕනේ වෙනවා ඒ omega තියා ගන්න බෑ. Let's discuss this thing later. Now we can write this relationship between this linear speed and the angular velocity. Right. You can write there in words, you can write the speed equals to the radius multiplied by the angular velocity. Okay. Then write the angular acceleration. It's alpha. We use the letter alpha for this. Angular acceleration. That's the angular acceleration. That's it. The angular velocity is not a constant, so it will accelerate. So the angular acceleration you can define as the rate of change of the angular velocity. Okay. Write the definition. The angular acceleration of a particle is angular acceleration of the particle is defined as rate of change of angular velocity velocity rate of change of angular velocity of a moving body angular velocity of a moving body at a moment right. ඒ වෙලාවේ angular acceleration is defined like that. It's called the instantaneous angular acceleration actually. Okay, let's consider t equals 0. That's the angular velocity. This is not now constant. Angular velocity is omega 1. And when delta t time is come to delta t, let's say this angular velocity at this moment is omega 2. Then the omega 2 is omega 1. In that case, is v is also not constant. It will be changed. This v1 and this will be v2 then. In angular acceleration, you can write change in angular velocity by time taken. That's all. Alpha equals delta omega over delta. That's your right equation. This is the general equation for this. You don't need to draw this again. Actually, we can write only this one. We will draw this again for the other equations. Right, that's psi unit of alpha is radians per second. And this dimensional formula t minus 2. And also write this angular acceleration is also the vector function. Alpha is a vector function. Its direction is also taken according to the right hand rule. In the case of when the angular velocity increases, the alpha direction of the alpha is same as the direction of the omega. But in the case of the angular velocity decreases, the direction of alpha is opposite to the direction of omega. You first write up to this point. I will give that point. Because there are three ways that angular acceleration occurs, right? The first way is that by changing the magnitude of the angular velocity, the angular acceleration can angular acceleration, right? But without changing the magnitude, that by changing the direction of the angular velocity also, it can angular acceleration. It can have angular acceleration. And third one is both the magnitude and the direction are changing. They are having an angular acceleration. Okay, then after that, you write there. You write there. I just like there. The angular acceleration can occur. Angular acceleration can occur in three ways. Can occur in three ways. The first one, right? First one, the change of magnitude without changing the direction of the angular velocity. Change of magnitude without changing the direction of the angular velocity. And second one, change of direction of angular velocity. Change of direction of angular velocity without change in the magnitude. Third one, right? Both the magnitude and direction changes. Both the magnitude and direction changes of angular velocity. Magnitude and direction changes of angular velocity. Okay. Then put this time, right? Current to this thing. The magnitude change without changing its rotating plane. Direction of angular acceleration is along the direction of the angular velocity. වෙනස් වෙනවා නම් විතරයි වෙනස්. plane එක වෙනස් වෙනවා නම් we have to consider it. Right there. Put this time right there. If only the magnitude of the angular velocity changes, if only the magnitude of the angular velocity changes, if only the magnitude of the angular velocity changes without changing the rotating plane, without changing the rotating plane, without changing the rotating plane, then the direction of the angular acceleration is, along the direction of the angular velocity. Along the direction of the angular velocity. Right, next point. Make a point and then right. If the rotating plane changes, the rotating plane changes, angular acceleration will be along the direction of the angular acceleration will be along the direction of the change of angular velocity. Change of angular velocity.
ඉව වෙන මෙහෙම ඉව ටික
Right. First, I'll explain this. Okay.
So in here, it's rotating. Let's say this, it's rotating to this. So I'll take the other side. It's rotating to this side. Okay. So it's rotating this side, the right hand rule. The angular velocity is in this direction. That's omega.
Okay, there's omega increasing, let's see. This omega increase.
The angular acceleration will be in this direction also. The acceleration is also in this direction.
Again, both. If omega increase, right?
And in the case of here, I'll consider omega decreases. Rotating to this side. But the omega decreases. The omega decreases. Then the angular acceleration is opposite to the direction of the angular acceleration in this.
This plane is not changing. The same plane, right? And in this case, the plane is changed.
This omega 1 is this, omega 2 is this, and the plane is changed to the other side. So,
I mean,
yeah, rotate them. Well, rotate the plane is changed.
in a plane එක මාරු නැත්නම් ඒක කියන්න පුළුවන්
තිබ්බා මේක මෙහෙම හැරෙව්වා. මෙහෙම හැරෙව්වා කියලා මේ හරෝන හයිස් කරලා දෙන්න. දෙවිලයින්
හැරිලා වගේ තියෙන එක.
Yeah.
ඒක ඔයාලා හොන්න. මේ ප්ලේන් එකට perpendicular තමයි omega 1. මේක මෙහෙර හැරෙනවා මේ ප්ලේන් එකට perpendicular තමයි. this way. Now මේ ප්ලේන් එකට perpendicular. then angular මෙහෙම alpha is then that's omega 2 minus omega 1 is in this way. Omega 1 omega 2 that's all. Omega 1 here, omega 2 here. Parallelogram එක. ඒකෙ මෙන්න මේ diagonal එකකින් කියන්නේ this is the change in omega, the delta omega. Right, so this direction is delta omega. So in this direction is the alpha. Alpha is in this direction. So this is the direction of change in angular velocity. Plane එක මෙහෙම තිබ්බොත් මෙහෙට හැරෙවුවොත් තමයි මේ omega වෙනස්. So a rotating plane එක change කරනවා. ඉතින් දැන් වේ උදෙන් කිව්ව කර්ම තුනක අනුව තමයි වේ. rotate වෙන plane එක change වුණොත් angular acceleration is different. තව velocities කියලා මේක discuss කරන්න ඒ කියන්නේ acceleration සම්බන්ධව centripetal acceleration later discuss. You can draw first this. Okay, I'll explain that rotation part again. First you draw these two, then I will erase this and then I will draw again, right? Then it's better because I'll make other method. You can first draw these two figures only. I'll explain this again. Clear? And then you run again. Okay. I erase this one. There, makan. This is one, right? So I'll rotate it like this. Can show it and here then. So I'll change like this. Okay. So when this also this here, this plane, the object is rotating in this way, right? The angular velocity in this direction. Now, so if I change this direction, so it's a change like this. So then also it's rotating into this direction. Angular velocity now it's upward. So that's the direction of angular velocity is change. Initially it's in this way, and now it is in this way. So that's why That's how these planes are changed. This is happen in the motion of a top. මොකද දැක්කා තියෙනවද බම්පර් කෙරෙනකොට දැන් top එකක් කොහොම කරකිනවා මෙහෙම කරකින හරි angular velocity in this direction අන්තිම හරියට විතර කරකිනකොට මොකද වෙන්නේ අන්තිමනේ මොළදී වෙනවා හරි එහෙනම් මේ කරකින ගම මේ axis එක ඔහොම කරකිනවා දැකලා තියෙනවා අන්තිමේදී මෙහෙම කරකිලා නතර හරි this is called the precision motion right so මේකේ මේ axis එක මෙහෙම හැරෙනවා හැරලා තමයි මේක rotate angular velocity මේ පැත්තට දෙන angular velocity initially is there now it's there so then there's then මේක මේ පැත්තට දෙතර angular acceleration එකක් now constant මේ බම්බරේ නිකන් කරගෙන constant speed කරගෙන no angular acceleration but if the angle the axis is changing axis is rotating like this so there's angular acceleration like this because the plane is changing initially it's this direction now it's the angular velocity in this way so it's changed so that's happen like this but ඒ වගේ precision motion but වගේ ලොකු ඕගල් calculation කරන්නේ නම් direction එකේ මේක දැන් black මේ plane එකේ තමයි ඔය direction එක that is omega 1 right this blue color plane the lines together horizontal plane this one is a vertical plane this then now in this right that's the one is in a vertical 90 magana ඒකේ ඩිරෙක්ෂන් එකේ මෙහෙම omega 2 ද මේ දෙක මෙහෙම කරගෙන ගමන් හරි තියෙන අර මෙහෙම කරකි එහෙම ගන්නම කරකේනේ so now the angular velocity is changed here so in vector diagram you can draw මේක 90 නෙමෙයි කියලා හිතනවා මේක පොඩි angle එකකින් වෙනස් නේ කියන්නේ 90 ම කියලා හිතනවානේ so omega 1 omega 2 these two are vectors so you can draw the parallelogram rule this parallelogram this is omega 1 and this is omega 2 so the parallelogram and in this parallelogram this is this diagonal represents the sum of these two and this diagonal represents the difference of these two so that is the delta omega that is omega 2 minus omega 1 so direction of delta omega in this way the direction of angular acceleration in this way change in angular velocity direction of change in angular velocity here is it okay okay on how about so now plane this plane is there the plane is there මේක ඉඳලා මේකට මාර්ක් axis එක වෙනස් වුණොත් සම්දී the change in velocity ගන්න කියලා කියන direction. ඔයගලන්ට ගොඩක් වෙලාට එන්නේ අර මෙතන වගේ කරපු this kind of rotations. Focus for row you can use it. Okay, the next term correct. Angular acceleration we discussed. And then write the next term that relation between linear, sorry, actually tangential acceleration and the angular acceleration. Linear acceleration means tangential acceleration. That's the acceleration along the tangential line with the considered moment. The right relationship between angular acceleration and the tangential acceleration. Angular acceleration and tangential acceleration. And the acceleration towards the tangential direction is in this way is at. There is a tangential acceleration. This is the acceleration which results due to change in the velocity, the linear velocity, like the linear speed. Right? Angular acceleration alpha. Omega is changes now. It's not a constant one. It cannot be a constant. Right? So how we get it? That's we know this V equals R omega. If V changes, then omega should be changed. Then delta V over delta T, that's U equals to the R delta V delta omega over delta T. That is the rate of change of the linear speed. So it's tangential acceleration. That is the angular acceleration. So the tangential acceleration is equals to the R alpha. To keep in mind that this acceleration is towards the go along the tangent. At the moment you consider this direction is not a constant. At here the tangential acceleration is this way, and here the tangential acceleration is this direction, right? So this is the acceleration along tangent, and it caused by due to change in the linear speed. Okay, this is you know. Okay, then I erase.
Okay, now you know the relation between that S equals R theta, that is the displacement relation, and velocity relation V equals R omega, and acceleration relation AT equals that's R alpha. Three relations, you know, right? Relations are. Another term is there, this the period of rotation. Period of rotation, or period of time you can put. Capital. That is the time taken to complete one rotation. To complete one rotation, that's one complete circle. We complete, that's how much the time is taken. Let's call it the period of rotation. කවටයක් සම්පූර්ණ කරන්න යන time. And then right, that's the time taken for one complete rotation. Time taken for one complete rotation is called the period of rotation. Is called period of rotation. You can write it like period of rotation is equal that the angle subtended at the center by one rotation. That's why one rotation, how much the angle subtended at the center divided by the angular velocity. One rotation එකක angular displacement, that means, so that time period, that's angular, some angle subtended at the one complete rotation, the total angle subtended at the center is 2π radian, and divide by the omega. So T, you can write this 2π omega. You know the angular velocity, then 2π is a constant value. You can find the time. If you know the time period, you can find the omega. So it's about the way you can write omega equals 2π over T. So T equals 2π omega. Okay, its unit is time. It's a seconds. Right? It's a seconds because it's a time. Next, write this frequency of rotation. Frequency. For one complete rotation, the time taken is a period of rotation, right? So period of time, we call it the periodic time. Okay, we can say, we can find this as periodic time. And the frequency means how many rotations execute per 1 second. So that is a reciprocal of this time period. Time period is a time taken to one rotation. Frequency is the, that's per 1 second, how many rotations occur. Okay. The right under the frequency of rotation, the number of rotations executed in 1 second, number of rotations executed in 1 second
is called the frequency of rotation. That is the frequency, that number of rotations divided by the time taken. Okay. We know that the frequency f, then the number of rotations, if one number of rotations, how much the time taken? So one complete rotation time taken is capital T. So f equals 1 over here. And then if you can write this 1 over T is 2 pi omega. Then you can write then. So in this you can say that omega equals 2 pi into f. Omega equals 2 pi. You can write it. As we call this also named as angular frequency, because this angular velocity is same as angular frequency. We both having the same way. That's only true pi is a constant. It's proportional, omega proportional to the f thing. So the omega is can be in the, that's expressed as a angular frequency. It's normally given that's RPM. The SI unit is radians per second, but generally they given the omega in the number of rotations per second, number of rotations per minute, like that. So that's called RPM and RPS. RPM is revolutions or rotations per minute. RPS is the revolutions per second. So that's the way they define. That's the given the angular velocity. You write up to this, then I'll do that. Okay, that's if psi unit of s, psi unit of frequency, that's it's per second, we call it hertz. Hertz, oh, that's per second, right? That's hertz. It is hertz. Simple it. Hertz. Right, that's put a sign right now. The angular frequency is generally expressed. The angular frequency is generally expressed as RPM. That's within bracket, that's a revolutions per minute, or RPS. That's revolutions per second. Generally expressed as RPM, or revolutions per minute, or RPS, that's revolutions per second. Then let's see how to find the omega with this one. So okay, yes. Omega, let's say omega is in RPM, that's 2 pi into that's frequency in RPM, right? To write in RPM, this is per minute now. So you need to divide it by 60. This is the value of RPM. You need to divide it by 60.
multiply it by 2 pi, and then you can find the omega. So this is then given the radians per second you can give. If it is in RPS, no matter, you can directly multiply it by 2 pi and you can write it as radians per second. It's a way you think. That's some example I'm given you. You need to know this example. This is 200 RPM of rotation. Then the omega you can write as 2 pi multiplied by 200 divided by 60. That is radians per second. Okay.
You multiply this by the
Is 20.94 radians per second.
this is the omega. You need to write that.
Second question, let's say it is 30 RPS, then the omega equals that 2 pi multiplied by 30 only. That is 65. So then 188.5 radians per second.
That's the way, right? You need to be converted it and then it
RPM, RPS, and then the one question.
can be pronounced as revolutions per minute, rotations per minute, or rounds per minute, so sound per second, like that. Anyway, the same meaning, right? Revolution means the one rotation. So rotation, oh, it can be rounds per second. Anyway, one complete round you consider, right?
Okay. Then uh,
the right of motion write the motion of a particle. Sorry, write equations of motion of a rotating body. Equation of a motion. Equations of motion of a rotating body. Equations of motion of a rotating body. With uniform angular acceleration. With uniform angular acceleration. The constant angular acceleration only with these equations can be used. Okay, then write some equations for this. Yeah, let us consider a rigid body rotating about a fixed axis. Rotating about a fixed axis with constant angular acceleration alpha. With constant angular acceleration alpha. Then right. And let its initial angular velocity is omega naught and let its initial angular velocity at t equals 0 is omega naught and the angular velocity at t equals t, that's at after time t. The angular velocity after time simple t is omega. It is kind of motion, right? And also right as t equals t is omega and it's covered the angular displacement theta during this time. And it's covered the angular displacement theta during this time. This diagram I'm showing you this all data. Theta at t 0 to t is come to this point. Omega naught initial and this omega come and the angular acceleration is a constant. This is constant angular acceleration. Okay. Then by the definition of alpha, right, then by the definition of alpha you can write alpha equals that delta omega Okay, sorry for that, sir. That's connection was that's a connection problem. Now it's okay, right? This omega equals omega naught plus alpha. This equation is similar to the equations of linear motions. There's omega corresponding to the final velocity, omega naught corresponding to the initial velocity, and alpha angular acceleration is corresponding to linear acceleration, and time. This is v equals u plus alpha t. Similarly, omega equals omega naught plus alpha t. You can write. You can get this equation using this. I'll show you that. So I'm not going to prove this all. And v you can write is r omega, and this is r omega naught. This a is that the tangential acceleration is equals to r alpha, and in r cancel. The same equation you can obtain with that. Linear motion very well. You have definitely it is similar. That's angular motion is similar. That only the relations you need to know. That's relationship between this linear velocity and angular, and linear acceleration and angular acceleration. Like this. Okay, that's all the physical quantities they're having the relation like this. Okay, then this average, right? The next one, average angular velocity. The average angular velocity with constant angular acceleration, you can write this average one. It's equals to the omega 1 plus omega 2 divided by 2. That's equals to the total angular displacement divided by the time. So similar to the total angular displacement divided by the time. So you can write in theta omega 1 plus omega 2. That's omega 1 plus omega 2 means it's omega naught plus omega here. According to this one. Yes. I got now. I got this initial omega and final omega. Okay, so that's initial angular velocity and final angular velocity divided by 2. Angular displacement divided by the time. Initial angular velocity is omega. Final one is omega here after time. And divide by 2. Multiply by, it's the second equation. It's similar to the SC equals V plus 2 over 2 into T. Then substituting from 1 and 2, theta equals omega naught plus. Instead of omega, you can write omega naught plus alpha. Just divide by 2, multiply by. So this omega naught t because omega naught plus omega naught, that 2 omega naught divided by 2 is 2 omega naught multiplied by t, and half alpha t square. Simplifying this, you can get this equation also. So it's finally you can subject the t here and then substitute there. So the equation you can write as t equals omega minus omega naught divided by alpha. And substituting in 2, you can write that theta equals omega naught plus omega divided by 2 multiplied by omega minus omega naught divided by alpha. And this omega plus omega naught and omega minus omega naught, you can write the omega square minus omega naught square. That's the difference in two squares. Divided by 2 alpha theta. So you can write this equation. I will simplify it one. I will write there. I have enough space to there.
I'm writing this omega star that's equals to omega naught star plus 2 alpha theta. So this is the shall erase this side. Okay. The final one I'm writing here, that's finally we can get omega star equals omega naught star plus 2 alpha theta. Okay. This kind of question, if someone asks a number of rotation, it's also you need to then know that the number of rotation during some time you can write rotations is equals to the theta, the angular displacement divided by 2 pi. 2 pi is the one rotation. That's in radians is a one rotation. The theta in radians you can write and then divide by 2 pi. The number of rotations you can calculate. Like in some cases, you can ask if the rotating wheel is rotating with some angular velocity. After some time, this is how much number of rotations is made before it stops. You can write it. Okay, clear? There are four equations. This is similar to the. This is similar to the v equals u plus 80. This is s equals u plus v over 2 to t. This is s equals ut plus half a t square. This is v square equals u square plus 2 a. Similar to that's the displacement is replaced with the angular displacement. And velocity replaced with the angular velocity, initial and final like this. And time angular acceleration replaced with the angular acceleration. These all equations you can use in similar way. You need to keep it in mind in these equations can only be applied in the uniform angular acceleration step. If the angular acceleration is changed, you cannot use this equation. Right? So I'll erase this one. Is it okay? You complete this. After this one, you have to write this. Is it complete? Finish it, right? Let me know. Right? Okay. In some cases, we have to discuss in questions if two or more wheels they are moving in contact or they are moving with the help of a belt like cases, right? So there's some relation between these kind of cases also you can consider. And then right there, the topic says wheels rotate in contact. Wheels rotate in contact. In contact. Wheels rotate in contact. Then right there, consider two wheels of Ferrari. Consider two wheels of Ferrari. R1 and R2. R1 and R2 are rotating in contact. දැන් එක විරෝල් එක කරකෙවුවාම අනිත් එක ඔටෝමැටිකලි කරකෙනවා. මම දැක්ටි තියෙන්න පුළුවන් ඕන එකක් හරි. Are rotating in contact without slipping. Without slipping. If V1 and V2 are the linear velocities of their points of contact. V2 are their linear velocities of their point of contact. Point of contact. These are the point of contact. Right, so here is R1 and it's rotated the omega 1. The radius of this is R2. Rotate to this side is R omega 2. And at this place, the linear velocity of this one is V1. And the other one also has the same direction. That's V2. Right? V1 and V2. It's like this. What should happen is at the point of the linear velocities or tangents, then we can write V1 equals V2 because at P and like it's in contact. So V1 equals V2. V1 you can write from the smaller wheel, that is R1 omega 1, R omega. The second one R2 omega 2. So this is the relationship between these radii and velocities. Right? යාළ හැකලා තියෙන පොඩි දැකිරෝධ වලින් එක එක ඒවා සම්බන්ධ කරලා තියෙන. ඔක තමයි ප්‍රින්සිපල් එක. කියන්නේ නේ. Here we can say this R1 to R2 ratio that's equals to the omega 2 to omega 1. If the small wheel has let's say this large wheel, so if R1 is greater than R2, then omega 2 is greater than omega 1. That means the larger wheel make a one rotation, the small wheel make a more rotation. So you can speed up or you can increase the angular velocity or angular this rotational speed by making the larger wheel and smaller wheels in contact. You know, in the bicycle also, it's connecting. It's also in contact, like homologic in contact, and it is connecting with the cable or chain. If you make this one rotation there, this will make many rotations. Let's say there are threads, and in here there's a 10 threads. That means if one rotate complete rotation, you make the parallel, and this will make that's a ratio to five the 5 rotations. අපි එක වටයක් කරකවන මේ ඉතිහාස රෝදේ වට පහක් යනවා. පොඩි එක වට පහක් යනවා කියන්නේ more larger distance speed up කරන්න පුළුවන්. ඒක තමයි making sure. හරි. You can get in. Simple. මේ එක දෙකම රවුන්ඩ් කරන්න ඕනේ. It's only you know this. Meaning I'm given that's mean that's R1 greater than R2, then omega 2 greater than omega 1. If one makes a one rotation, larger wheel makes one rotation, smaller wheel makes more than one, many rotations. That's the number of rotations they make. The ratio between them is equal to the ratio of their threads or radius.
or make disconnect now, right? So write example. We'll do this example and then stop the class. And write example. One time we're gonna have any monkey right there. The angular speed of a motor wheel. The angular speed of a motor wheel is increased from 1200 rpm to 1200 rpm to 3120 rpm. 3120 rpm in 16 seconds. In 16 seconds, right? 16 seconds. Right, I will write it again. Right, they write the angular speed of a motor wheel. The angular speed of a motor wheel increased. Motor wheel is increased from 1200 rpm to 1200 rpm to 3120 rpm. 3120 rpm in 16 seconds. In 16 seconds. Then write the question. Part number one. What is its angular acceleration? What is its angular acceleration? Assuming the acceleration to be uniform. Assuming the acceleration to be uniform. And second part, how many revolutions does the wheel make during this time? How many revolutions? How many revolutions? Okay, then write how many revolutions? How many revolutions does the wheel make during this time? The wheel makes during this time. Right. Do it.
All right, let's see then. You have chance to the ball. Then there are results. ළමයින් ඇවිල්ලා දැන් තමයි ළමයින්ට නිකන් පත්ති කරන්න ඕනේ. දෙකේ ළමයින් ඉතින් දැන් මේ සම්පත පටන් අරගෙන එහෙම මේ මාස දෙක තුනදී මුළු සිලබස් එකම උගන්වන්න කපා අමාරුයි. පුත්ම නොකරපු අය ඊනට දැන් තමයි කතා කරලා අහන්නේ. ඒක පන්ති ආරම්භ මොහා කරන්න කියලා මට කිව්වේ. The omega naught you can write is the initial, if you get 2 pi multiplied by this 1200 divided by 60. This is radians per second. 60, 20, right? This is then 45. I'm using this pi. So finally we will substitute and get the answer, right? It's easy. And then the omega final velocity is 2 pi multiplied by 3120 divided by 60. And then 6 5 2 104 pi radians per second. The angular acceleration is then delta omega, this 104 pi minus 45 divided by the time is taken 16 seconds. Right, that's alpha, you know that's alpha equals delta omega over delta t. So that's summarized. There's a change in angular velocity, that is 64 pi divided by 16, that is 4 pi radians per second. The value of phi you can substitute there, that's 1 point. You can substitute as 3.1514. Just 12.56. 57 radians. This is the angular acceleration, radians per second. And then the angular, they ask a number of how many revolutions to this will make this time. And then you can use this equation, that's theta equals omega naught t plus half alpha t square. Theta plus find how many radians they rotate. Right, so omega naught 45, t is 16 plus half, alpha is 4 pi, and t is 16 square. And then the 2 cancel. 2 5 16 2 5 6 multiplied by 2 5 12. 16 we get our answer by 2 70. (72 pi into 16), and the number of revolutions, let's say n is theta divided by 2 pi. And then 72 into 16 into 5 divided by 2 pi. If 5 cancel, so 8 into 72, then that's 8 into 72, 16 and 8 by 6. So 576 revolutions each day. Right? That's the way you use these equations. Okay. I'll stop classes from this point next week. Okay, not next week, actually, this coming Wednesday, we will start the physical class, right? I'll come to the night week. And let me, and then I will bring some tutorials to you to do that. Okay, I'll stop the class. Bye, good night.